think it's few minutes have passed, so maybe can start. Dieter and Peter. Are you ready? Good.
Yeah, of course.
Okay, so welcome everyone, and thank you for joining us on today's webinar. My name is Alexander Schröder, and I'm in the project management and sales here at ABB. I welcome you to our first tech talk today. It's for upgrade of Procontrol P14 master station. We are holding this tech talk directly from the power generation in Mannheim, or you can also say from our home offices. Of course, due to Corona, it's very difficult for us traveling worldwide and visiting you customers. So please excuse us if we are not perfect here in an online presentation. We are engineers, and also this is new for us, a new format. So at the beginning, I'd like to say a few words about WebEx, about this tool here. First, and maybe most important, you can ask questions during the presentation. And on the right-hand side, you will find a Q&A panel for questions and answers. Our presentation will take around 45 to maximum 60 minutes. And the first half an hour roughly will be presentation, and in the end, we will have a question and answer session. So you can ask during the presentation or submit questions in the end. Anyhow, we will get back to it. For your information, this event is being recorded. You can also listen and watch to it in the end, afterwards in the next days on our homepage. And you are all muted, so we cannot hear you. You have to ask the questions in the chat. Okay, now you see a picture of myself on the right-hand side. I'm your host today, Alexander Schröder. I'm in the service global markets team for now 5 years, and I will be your host today. Now I hand over to our presenter, Dieter.
Thank you very much. My name is Dieter Fleck. I'm with ABB now more than 20 years. Since 7 years, my main focus is on the process automation, instrumentation, and electrical service of ABB's globally installed base. Prior starting my technical part, I would like to hand over to Peter Beer, Head of Service Global Markets, who appreciate also to welcome you to our today's Tech Talk.
Thank you, Dieter. You can hear me, yes? Okay, fine. So good morning, good afternoon to everybody, and also a very warm welcome from my side to our first Tech Talk session. I'm very pleased to meet you in this new virtual format, and please let me briefly introduce our team and myself. My name is Peter Beer, 52 years old, father of a 12-year-old daughter, and a part of the ABB family since approximately 30 years. In different roles. In the role as a manager responsible for the service global markets, I am heading the team of dedicated service managers, as you can see on the picture. Some people, some colleagues are missing. Maybe you know them from personal meetings and from video telephone conferences you have. In ABB Power Generation Germany, we are supporting our installed base customers since the 1990s, the early 1990s. And worldwide, we are addressing customers in approximately 60 countries with products and services related to our automation and electrical systems. Please take over to the next slide. Yeah, health and safety. Health and safety is one of our most valuable topics within ABB. As you know, the global pandemic, Corona pandemic, is changing everything, also the communication to you. Therefore, we use this virtual communication platform, but of course, we are looking forward to meet you again personally. I would start with the so-called safety moment. Some basic messages regarding health and safety are shown in this slide. And first, let me point out that ABB is committed to the highest standards regarding health and safety. Look at ourselves. Our employees and contractors are equipped. They are trained and instructed to fulfill highest performance regarding health and safety. but also being at customer side, ABB will fulfill customer health and safety and local country regulations, for example, for COVID-19. And this is a very important obligation during this pandemic. But we need also your valuable contribution. Please support and guide ABB regarding your local rules in order to follow the common goals of health and safety. This is very important. Finally, our target is to ensure safe work environments and to create a culture of health and safety that support an optimal business performance for customer and ABB. As a summary, and finally, we can say ABB is targeting a zero incident policy regarding health and safety. So finally, I wish you a very interesting and fruitful Tech Talk session. Today, we are presenting the Tech Talk session upgrade for Procontrol P14 Master Station. And for that, I would hand over to my colleague Dieter again, who will lead us through the presentation.
So, thank you very much, Peter.
Thank you.
Dear everybody, I also like to welcome you again on our today's session, why and how to upgrade your existing Procontrol P14 Master Bus to a fiber optical interface. In total, we will have today 5 agenda topics that I like to present within the next 30 to 40 minutes and allow about 15 minutes for replying your questions on the Q&A. First of all, I will give you a short introduction. Then we will move to the technical description. And finally, I will show you benefits and references coming to the summary. Whenever you have questions or comments, feel free using our Tech Talk chat. In the end of the session, we appreciate listening your feedback to the newly launched Tech Talk series when leaving the WebEx. Now I like to start with a short introduction of Procontrol P14 Lifecycle and its history. To understand ABB's policy, I would like to begin with Procontrol P14 product lifecycle and ABB's technical approach, keeping our customers' installed base up to date. Basically, all P14 equipment is divided into 4 life cycles related to their age. There is first of all the active, the development phase. As the second one, the classic maintenance phase, coming to the limited service phase and the obsolete limited support phase. Related to the phase, our customers will provide it with fully product support and spare parts in active and classic phase. However, when the product phase reaches limited or even obsolete, the spare parts availability becomes quite difficult. Therefore, ABB's approach, starting already from classic phase, actively supporting our customers with a seamless upgrade strategy. The main goal is the lifecycle policy evolution without obsolescence. What we found very often on sites are obsolete and defective modules that mean a high risk for continuous unit operation and causing trips. When ABB will be involved, units are frequently already in a critical conditions where solution requires much more efforts at once than performing regular minor upgrades. Our goal is therefore providing you awareness on your product lifecycle state to plan necessary upgrade time and budget-wise. Before getting critical, for example, by unscheduled plant shutdown to defective communication equipment. Considering the overall life cycle of Procontrol P14 bus communication, it's starting already in the 1970s, where you can find continuous development and innovation up to now, and still continuing as already shown at least up till 2035. In today's Tech Talk, we will going to look into the upgrade of the Master Bus Station 2nd generation to FDDI bus. which means fiber distributed data interface. Communication, which means the backbone of your plant automation system. Comparing the different communication modules still in operation globally on your plants, their life cycles are partly already obsolete, limited, or classic. As you can see here, and from the cycle, from the development, starting with the TK01 communication module, coming to the TK5 up to the TK50, which is currently in active life cycle state. From our point of view, it is essential now to begin considering this issue in terms of spare part availability and reliability after many years or even decades in operation on your plants. This is, from our point of view, of high significance to save your investment and extend your plant life cycle without having to replace the complete automation system and avoiding unscheduled outages or plant trips. On this topic, I would like to show you how a seamless transition of existing coaxial master bus to a state-of-the-art fiber optical bus interface is possible. As you can see on the left side, master bus installation will be converted from a copper base coaxial interface to a fiber optical ring interface. In this case, to a redundant fiber optical ring that can be extended up to 10 kilometers. Coming to the next slide, here you can find a typical insight which components of the existing installation have to be modified during upgrade. While master station A and B, as well as several devices used for master bus communication, will not require any longer, only existing coupling devices will be replaced with same quantities. This means if you are using, for example, 2 redundant TK05 currently, you will replace them by 2 new TK50 modules. As you can see on this picture here, the MSA, MSB will be obsolete and will be replaced finally by a redundant ring using TK50 only. Now we are coming to a typical upgrade procedure and what steps are to be taken during this upgrade. Starting with the pre-installation of the fiber optical connection, removal of the existing communication modules, as well as installation of the new equipment and some minor modifications of the existing wiring for monitoring. Here I like to highlight that some activities already can be prepared and executed prior and after the unit shutdown. One of it is, of course, the installation of the fiber optical cables that can be already replaced prior to any plant outage, as well as the final components that will be no longer in use can be dismantled, and the blind plates can be also put after the plant is already back in operation. This saves finally time on the required overall unit shutdown time, and upgrades can be fitted even in shorter shutdown periods if you do a detailed and proper preparation of this upgrade. During this upgrade procedure, you have to exchange components as shown here. Basically, you can already see that the overall quantities of components will be reduced. This means in the old configuration of the master bus station, you're going to use in a redundant installation 2 times the TK05 and FT05, as well as the bus termination modules FK05 and IL06. And in the new redundant fiber optical configuration, you're going to use only 2 redundant TK50 and of course the fiber optical cable that will replace the obsolete coax cable. Besides the benefits of the reduced hardware, there are many more improvements of the latest communication module TK50, starting with the bus speed, quantity of data telegrams, ease of the bus configuration, as well as excellent EMC behavior due to the fiber connections, which is no longer a copper-based connection. I will show you all benefits in detail based on TK50 when moving to the next agenda topic. Prior to any upgrade, we always have to remember that it is necessary to ensure existing installation is ready for the upgrade. As you can find from the checklist, you have to take care of a few practical matters which you have to consider in advance. First of all, you have to consider that the engineering and diagnostic tools, as well as the engineering and PDDS, need to be up to date. The firmware prompts of the coupling modules TS01, TS50 need to be replaced. This means they also need to be upgraded. The stations, of course, you have to check if the first 4 slots are free. This is the difference between the TK05 and the TK50 is that the TK50 requires 2 slots instead of 1 as before the TK05 requires. Of course, a short plant shutdown is required for the replacement. You cannot do it during the plant is online, and the device compatibility is to be considered, as we can see on the next slide. Looking to this figure, I would like to emphasize again the importance of the device compatibility required for the upgrade. If you recognize now your installation to match the green highlighting, you're close to upgrade your installation to the next level. This means to the 3rd generation. In case you have still installed the 1st generation of devices, a more specific migration is necessary, and this will not be reflected in detail during this session. Anyway, migration is always possible, and we would appreciate if you contact us for a customized solution after our session. You can see here the former way was the direct compatibility between the 1st generation and the 2nd one, and the 2nd and the 3rd one. Meanwhile, we also have experience and the solution to migrate the 1st generation to the 3rd generation directly. Coming to this slide, you can see here a typical timeline for such a master bus upgrade. As you can see here, from the contract signature to the overhanding to customer, we are talking roughly about 7 to 8 months, which is the issue that we're starting with the signature, going to the engineering, which is quite short with maximum 4 weeks, coming to the manufacturing, which is the lead time for the overall project execution time with 5 to 6 months. This is related to the production in our factory for the TK50 modules. If you consider to give us in advance some information, Then we could also improve this by setting internal forecasts to our factory and getting devices even quicker than the 20 weeks. Then we see we have deliveries of course, about 2 weeks, and the installation preparation, which is, for example, the preparation of the fiber optical links, the fiber optical cables inside the cabinets. Then we come to the installation during the outage, as described in the overall migration procedure, which I show you before, continuing with the commissioning of the unit. And of course, overhanding to the customer. This all is in a close coordination with the customer and the scheduled shutdowns of your plant. For example, the annual maintenance shutdowns.
Dieter, I want to say something. We have already received some questions in the Q&A chat.
Okay.
And I see there's one question which perfectly fits to this project overview. I'd like to ask you here. The question is there an FAT required for the upgrade from master bus station to FDDI?
Okay, thank you, Alex. So the question is, of course, very valuable, as you don't see any FAT in this project overview, in this typical timeline, and in fact, it is not necessary at all. During the upgrade, only the communication is affected, and so there is no need to do any factory acceptance test for the TK50 module itself. All the communication tests and communication commissioning can be done during the on-site commissioning.
Okay, good. Thank you, Dieter. And for the other questions, I think we will wait for the Q&A session in the end.
Okay, perfect. So finally, I would like to present you the main reasons why you should consider this upgrade for your power station. It's not only the fact that previous technology is more or less outdated and spares are only very limited or no longer available. Moreover, it has to be said that the new FDDI interface provides you as customer improved features and enable your system to extend its life cycle. Looking at the new coupling device TK50, you will improve your system efficiency and reliability with a proven fully supported technology. Actually, you even don't need to recommission the existing system or to modify the existing function group logics. This is the main benefit, as already shown during the procedure, that you simply upgrade the bus communication and the bus interface, and all the existing applications kept unchanged. So after upgrading to FDDI, there is, as just mentioned, no bus reconfiguration required. By using a fiber optical connection, also the EMC properties are excellent and data transfer rates are increased by 10 times in comparison to the TK05. Furthermore, you are able to extend number and distance of P14 stations. Additional to previously mentioned benefits, even the quantity of required stations modules can be reduced, as you can see on the right side, and even obsolete master station can be reused with additional TK50 as an additional station. As you can see here on the right side, the benefits in reducing the modules the TK50 in our case, replacing all the station bus and master bus modules used currently in your installation. On the following slides, I like to show you recent projects with similar scope that ABB successfully completed. The first reference was completed in Czech Republic within a very short time during a planned 1 week only outage of an automotive customer. Together with this customer, we prepared detailed upgrade activities for steam turbine power generation and were able to finalize all required site activities during 1 week only. Another recent master bus upgrade was performed at Kazakhstan in close cooperation with our local customer. This upgrades reflects a typical gas turbine power generation application where we upgrade the existing installation, including new cabinets, within 3 weeks completely. This was even less, if you remember, as indicated in our typical time schedule. It always depends on the quantity of your existing installation, as well as your outage time you planned for your annual or half-annual outage. With all the mentioned aspects taken into consideration, I like to conclude and with an evolution concept for the presented master bus upgrade in my summary. Looking on the current status of your existing installation and your foreseen plant life cycle, we like to provide you with an efficient and easy upgrade strategy to keep your automation plant assets up to date. First step could be a master bus upgrade to FDDI, including the related tool upgrade to ensure that your ABB components are up to date and fully supported at any time. From the timeline or concept you see where you are now, you have usually the master station 2nd generation in Lifecycle limited or even obsolete. And of course, you have the Procontrol P14 modules in Lifecycle limited obsolete. Within these upgrade, this is the first next step, is an upgrade concept to make the bus communication ready for future and going to Lifecycle active. And in a further step, you can also think about upgrading the obsolete P14 modules to currently active modules. But basically, as a preparation for all other evolution steps, you should start with the upgrade of these master bus. So now we are coming to the Q&A session.
Yes, thank you, Dieter, for the presentation. And I see in the chat we already have a lot of questions here. Yeah, I will start with this one here. Can an existing master station racks being reused during the upgrade while replacing TK05 with TK15?
That's true. I already mentioned this and showed this also. The existing master bus stations or racks A and B can be reused after the upgrade, where they are in principle obsolete, by using fiber optical cables and new TK50 modules as fully operable new stations in the new fiber optical bus system.
Okay. Then I have another question. You somehow already answered it. Nevertheless, I still want to ask it. Is it necessary to have a 4 weeks shutdown for the upgrade?
4 weeks is in principle, let me say, a time which is mostly sufficient for this upgrade, but you can even improve the time by doing some optimizations. If you're doing a detailed preparation work, for example, by already preparing the fiber optical cabling, also informing the request for needing communication modules, you can improve and even bring down the time, as we see in our references.
Maybe I can add something. We have shown also in our one reference project in Czech Republic that we can do that in a much more shorter time. We have shown that we have an upgrade for a few cubicles within 1 week. Sorry, in 1 week. So the question is, how big is the installation? How many cubicles we are dealing with? And of course, the preparation should be done, as Dieter said. The cable is there, and all the things that can be prepared are done. And then we are using the planned shutdown. This is the most important message we have. We are using a planned shutdown. We do not need an unplanned additional shutdown of the unit. This is very important to understand. And with the projects we have realized in the past, we all the time only use planned shutdowns of the units.
Okay, thank you, Peter. Maybe also a second question for you. Is it possible to support from customer side during the installation or also commissioning? Peter.
This is a normal approach for us to deal with local companies for installation and commissioning, and also erection, installation and erection. Normally we are providing supervisors to guide this work during the on-site services. And from my perspective, it's also a chance for customer person to get involved, and let's say to be familiarized with its new system, and it's some kind of training on the job. Yes, it's not a problem. It's a feature, let's say, to include customer to this kind of work for the installation and the commissioning, guided by our specialists that are on site.
Yes, thank you. Okay, good. And Dieter, maybe the next one for you. Is there any rewiring or relocation engineering necessary while replacing old 88TK05 by new 88TK50 modules?
So the only rewiring in the master station is required minor rewiring for the monitoring of the master station. In principle, you can simply replace the TK05 by the TK50 on the existing rack. The only thing you have to have in mind that you need, instead of 1 slot, you need 2 slots for the TK50. So this, as already mentioned, you have to check prior to the upgrade. And in worst case, which is not standard, the slots 3 and 4 on the master station is already used by some additional module, and then you need to reallocate this module. But in principle, you only have to do the replacement of the coaxial bus cable by the fiber optical bus cable. This is the big advantage.
Okay, good. Next question. What about the EMC behaviors for the new 88TK50 modules?
The EMC behavior inside the cabinet is definitely similar to the TK05. The EMC improvement means that you are now using fiber optical cable, which is no longer copper based, and therefore from the EMC properties much better than before. Of course, you can also think about improving your existing cabinets with additional EMC measures, but for the moment, or from our experience, it is sufficient to replacing the fiber optical cable only.
Okay, good. Okay, Dieter, then I have here a really technical question. Let's see if you can answer this one. What grade of fiber optic is required? Is it OM1, OM2, 3, or 4? Can you answer that question?
For sure, it is specified, but for this, I would like also to ask my colleagues to answer in writing.
Okay, good.
The recommendation, let me say, by the factory itself.
So we will get back to this question afterwards.
Yes.
Okay. Then next one, do I have to perform the complete commissioning again?
This is the big advantage. No, you just have to recommission the bus communication, but all the function groups and the existing commissioning of your plant, of your unit, don't need to be repeated. So as soon as the bus communication is back in operation, back in, you are fine. Huh? You don't need to recommission your plant again.
Okay, good. Maybe the next one again for Peter. Peter, can you give us some details about hot swapping the new TK50 modules? Is that possible?
Yes, it's possible because of the redundancy. These modules are installed in a redundant manner, so two modules are sharing the functionality, and they are linked to each other. And if you want to change one module, exchange one module during operation, you can only plug it out, and the other module will take this task alone. And for that short moment, you are not redundant, of course, but the functionality is fully given, and so it's because of this redundant approach. It's not a problem to have a hot switch over between the modules, a hot exchange between the modules.
Okay, good.
Yeah.
Peter, also the next one, maybe you can give us some details for the life cycle. What is the life cycle from this new 88 TK50 module?
So the life cycle is definitely active, of course, as you can see from the history, and it keeps definitely active. So from the development in the past years, maybe also our customer heard about, for sure, because these modules are already developed before many years, and we have very good experiences with it. We face some minor issues with some electronic elements on this, but we could solve this issue, and we can still produce further TK50 modules also in the future. And due to its functionality and its stability, we keep also the TK50 active for further years. In case that there are some changes, of course, we will inform our customers prior and, of course, many years in advance. For the life cycle itself, I like also to add that the life cycle stages will usually turn in decades. So when you leave one life cycle, it's at least a decade between. Huh? So even if the life cycle changes from active to classic, you get still the full support of the device.
Okay, thank you. Good. And next question, is there a possibility for a stepwise upgrade using MasterBus and FTDI in parallel?
Yes. It's also mentioned on the previous slide where I'm showing the current life cycles from TK01 to TK50, and there is a coupling device called KS50 which can be used to do this coupling. However, what you should consider is that this means additional installation and cost effort on site. So if you have only a small installation with a few cabinets in a unit, it makes most sense to think about replacing the bus system at once.
Okay, good. Now only a few questions are left. Let's see if we receive some more in the Q&A chat. The question here is, how many modules should be kept as spare parts for warehousing?
That's a very good question, of course. From our point of view, we recommend at least 2 TK50 to have on your store to serve some failures of redundancy, to replace them ad hoc and can reorder. Usually we give the recommendation having 10% of your complete TK50 installation as spare. But as minimum, we recommend 2 TK50 having on your stock.
Okay, thank you. Another question about the QT03 module. Can the 88 QT03 modules be used in this FDDI system with 88 TK50?
This is the connection between P13 and P14, and the connection is still working also with FDDI. But as we have seen in the slides, the QT03 itself is in an older lifecycle generation, and not let's say, if it's broken, it's hard to repair or to exchange that module. So and the good news is that there is a new solution for that. If the QT03 coupling to P13 is not working anymore because of defect of the module, not because of the system itself, the defect of the module, there's a new coupling between P14 and P13 with a module on P14 side that's called TP50, and on P13 side is PK08. These are two modules, and so it's possible to exchange it completely, this interface, or to leave it as it is. Yeah.
Okay, thank you, Peter. I see another question. Currently, we have as engineering tool KISS. Is it recommended to have another engineering system?
Definitely not. It was a kind of renaming, starting calling the engineering system KISS. Currently, we simply unify the naming to P14 engineering. And the final engineering system for the moment is P14 engineering, which is equal to KISS. It's just another naming convention.
Yeah. It's completely the same software. You only change the name because of the English meaning of this KISS.
Good, thank you. And currently the last question here. Can I do an upgrade without unscheduled outage? So can I do an upgrade only within a scheduled outage? Or yeah, what's necessary here?
No, as explained, you can do the upgrade whenever you have at least a time period of about 1 week, as Peter already explained, and you have this time window. You can even do the upgrade within an unscheduled outage. As soon as the modules are available from factory, which is the long lead item in this chain of upgrade, then you can do it even without an with no scheduled maintenance outage. So whenever you have some unplanned outage and it requires, I don't know, 2 weeks, and you know this in advance that you have to stop your unit, then you can also fit in our upgrade inside this time frame.
Okay, good. Then thank you, Dieter and Peter.
That's another question. What about the modules?
Oh, okay. Yeah, I have to scroll down. Sorry for that. What about the modules used until now, like the old SR04, SR07, and EU01 modules? I think from second generation.
Yeah, this is also a good question because Lifecycle is already coming to limited. And so in principle, you also have to think about upgrading them. But as a first step, as I already tried to explain, is you have to make, let me say, your bus and your engineering system ready for this upgrade. So in the first step, you have to prepare your plant communication on active life cycle. And in the next step, you should also consider the upgrade to SR50, SR51 modules.
Yeah, but Dieter, we have to be careful. In that case, as a comment, I see that this question is coming from Thermo Piper. We do not have to mix two different things. One thing is to get the engineering system clear to support the new modules, and this is done with KISS. If KISS is available, then we then the modules are fully supported. In the other message, and that have to be very clear, is the TK50 upgrade has no impact on EU01, SR4, and SR7. This is not mixed with each other. So the answer is you can do the upgrade of TK50 without caring about SR4, SR7, or EU01. But you have to, and this is a totally different story, you have to be clear that these modules are also limited and with the spare parts and so on. And that's the reason why we have succeeding modules for this. But this is not the story of TK50 upgrade. Yep. So the answer is clearly TK50 upgrade from TK05 to TK50 has no influence on the usage of SR4, SR7, and EU01. These are two different stories.
Yeah, that's true, and we will also consider this issue during then another session when coming to upgrading the P14 modules in detail. But Peter is absolutely right and clarified it. This bus upgrade has absolutely no impact to the existing installation of the P14 modules.
Yep. So we do not have to upgrade them because we do an TK50 upgrade. This is not related to each other. These are totally different. Even under TK50 fiber optic, these modules will function, will have the full functionality. This is not limited in somehow.
Okay. Maybe, Dieter, we can just go back to slide 17 maybe and give just an overview for that.
Just a moment.
Yes.
Back to 17, you tell.
Yeah, right. This is where we showed the 3 generations.
Of course, here.
So
this one, yeah. You can. Everybody can see it. Yes.
Yes.
Okay, perfect.
So because we are still at that question here, and he's asking because we see in the second column some modules, so these SR04, SR07, EU01 also in the second column, and now we are talking about TK50 in the third column from the third generation.
Mm-hmm.
Maybe Dieter, you can give a short explanation about that.
The column with the third generation shows the modules which are currently in active state. And this means if you are doing a new installation now, you would use these modules. In case that you do the bus upgrade, you still can, with the TK50, you can still use these modules here. You only have to know and to consider that if some of these modules, which are also mainly or completely are already in limited life cycle, that you may don't get a replacement part of these modules. For example, the EO01. But this means not you have to replace, to clarify it, already by the new modules in one go. No. If you're doing the bus upgrade.
Yeah, thank you, Dieter. So I think the green arrow between second and third generation shows these two.
There's an expression for that. That means down scale. It's compatibility. So you can use all these modules in the middle of the second generation, also with FTDI bus, because they are compatible in regarding the work on the bus. They are working in the same manner as before. But if some modules are broken, for example, the AU01, you have to resample it with the newest version, the EU50. That's the message. But you do not have to change these modules because of an FTDI bus upgrade. This is not necessary. They will work as before.
And here you can see also the importance when you're upgrading to TK50. The communication between the cabinets is the most important issue to start the upgrade with, because if simply one in-output module breaks of the old one, which is limited or obsolete, then okay, you miss a few IOs. If you cannot handle the communication between the cabinets, if you are using the TK05 and it breaks and you have no replacement and no spare, then you lose a complete station in this case.
Okay, good. So now we have answered the question. Thank you. So we can go back at the end.
Yeah.
No more questions are left. So I say thank you to everybody who joined today. You can get in touch with us. Here you can see a mail address of our department, but nevertheless, I think you have everybody your dedicated sales engineer, and you can get in touch, of course, directly. Also, I see if you like to get a presentation shown here, that's possible. We can also share that presentation with you. And around next week, you will also receive an email from us where you can find the recording of today's webinar. I also like to give you information about our next Tech Talks. We have already scheduled 3 more Tech Talks here. First, it's the upgrade of gas turbine control. And the second one is the upgrade of the HSI system, as we talked about, KISS or P14 engineering. And the last one is the upgrade of the Procontrol P14 modules. This is also what we somehow talked about in the end. So maybe you find an interesting other Tech Talk here where you like to join. Nevertheless, I say thank you for joining this Tech Talk. And if you're leaving WebEx now, you will receive a short survey with just 1 question. We appreciate your feedback. This format is also new to us, and we hope you've enjoyed it. Thank you for joining.
Thank you very much, everybody.
Thank you very much. Take care.
See you on the next Tech Talk.